All right, so our lesson today is going to be graphing linear inequalities. Before we have graphed linear equations, just a straight line, but we haven't graphed linear inequalities. Okay, so I want to do that because it involves shading our areas. Because with inequalities, you've got if like x is less than 1, then it's every number less than 1, right? So we have to shade that area. And then the same thing when we're doing a systems. If we graph a linear system, then it's where the intersection is. But with the linear inequality system, the shading's going to be that area that's for both inequalities. Okay, we'll get into it a little bit in just a minute. All right, but before we start that, I want to look at just refresher about inequalities. Let's check our solution on this. So if we've got the equation 2x plus y is less than negative 3, and they want us to check to see if this ordered pair, this x and this y, is a solution to that inequality. So what we're going to do, we're going to substitute x with negative 1 and y with 9. And then we're going to see, is this inequality true or false? If it's true, it's a solution. If it's false, it's not. All right? So 2 times negative 1 is negative 2 plus 9 less than negative 3. Well, is 7 less than negative 3? No. All right, think of your number line. If I had a number line, here would be 7 and here would be negative 3. This way's going less, right? So no, less than would be this way. Does not include 7. So no, this is not a solution. Let's look at this one. All right, so this is our x and this is our y. Will this make this inequality true? So we're going to substitute x with 2 and 3 times y. Y is negative 2. Is it greater than or equal to 8? So 2 minus 3 times negative 2. Well, that's plus 6. So 6 plus 2 is 8. So is 8 greater than or equal to 8? Yes, they're equal, right? If it just said, if that or equal there wasn't there, if that line wasn't there, then it'd be no. But they are equal to, so yes, 2 negative 2 is a solution. All right, so let's look at the graph, what it would look like. So the graph of a linear inequality in 2 variables shows all the solutions of the inequality on the coordinate plane. Remember that a dashed boundary line means that the points on the line are not solutions, because that dash, remember, if it's greater than or less than open circle, then that's
Dr. Fee and Mr. Huffman, we're in my office whenever you guys are ready.
that means it's not included, it's not or equal to, right? Solid line, solid circle means it is equal to, okay? So this would be a dashed line, this would be a solid line. All right, a solid boundary means they are solutions, okay? So if I'm looking at this, y is less than negative 2x. Remember, this is slope-intercept form, so my y-intercept's 0, my slope is 2, go up 2 to the right 1, up 2 to the right 1, or either down 2 to the left 1. So there's my line. Because it's not or equal to, it's a dashed line. So now we have to determine which side of the graph of the line are my solutions. Well, it says that y is less than, so that's going to be underneath the graph, okay? kind of think that if I had this on a spinner and I straightened it up, it would do like this, right? But if I bring it back down, it does like this. So it's underneath it, it's less than. And we'll talk about a test point in a minute, okay? But this is just to let you know that everything on that side is a solution. So if I pick a point, let's just say this point right here, 2, 0. If I was to plug that in for x and y, so 0 is less than 2 times 2. So 0 less than 4. Yes, that's true, isn't it? So it's a solution. What if I picked this point, negative 2, 0? If I plug it in, 0 less than 2 times negative 2, so is 0 less than negative 4? Well, no, it's not. So this point's not a solution. That's why it's not in the shaded area. The shaded area are your solutions. All right, every point in that shaded area would make this inequality true. Okay? All right, so when you're graphing an inequality with two variables, x and y, graph the boundary line of the equation. So we're going to graph it like we're doing a normal line. Make sure you look if it's dash or solid. And then we're going to use a test point that's not in the boundary to determine whether it's a solution or not. Okay? So let's look at this one. And this will kind of give us a refresher on graphing our lines, right? So this is y is less than or equal to 2. Well, that should give you a little red flag right off. There's not an x, so that means it's either vertical or horizontal. So it's telling us it's crossing y at 2. So here's y. We're going to cross it. Here's 2. We're going to cross it. Now, this has got a solid line, so it's r equal to. So we're including everything on that line as a solution. So it says all my solutions, because y is your solution, all my solutions are less than 2. Well, that would be everything down here, wouldn't it? Okay, now we can test that, and we'll get what's called a test point. And I always like to use the point 0, 0, as long as it's not on the line. Okay, if it's on the line, I use something else. But you can use the test point 0, 0 and plug it into your equation. So is 0 less than or equal to 2? Yes, it is. So that means, yes, this is a solution, and we always shade the side that's true. Okay, these are all true. And then also, it's underneath my line, so it's less than. But if you're not sure, you can always use that test point. All right, we're going to graph this line. Now you can either use your x and y intercept, or you can put it in slope intercept form. If I do my x-intercept, negative x is greater than 2. So x, we got to divide by negative 1. What happens? We reverse our sign. All right? So my x-intercept's negative 2. My y-intercept would be y is greater than 1. So we're going to go to 1. So this is, there's not a solid line, so we're going to have a dash. Okay. Now, you might want to put it in slope-intercept form. That way you can have a little bit more accurate graph. So let's do that. Let's do 2y is greater than x plus 2. And then we're going to divide everything by 2. So y, almost put an equal sign. This is 1x, right? So y is greater than 1/2 x, because 1 divided by 2 is 1/2, and 2 divided by 2 is 1. So our y-intercept was 1, go up 1, to the right 2. Okay, so see, and we down 1 to the left 2. See how sometimes you can be a little more accurate on your graph by using your well, my pen doesn't want to work, by using slope-intercept form. Okay, so remember it's going to be dash. All right, so our equation says all my solutions are greater than, so I'm going to say that they're up here. But let's do a test point. So my 0, 0 is not on the line, so I'm going to just plug in 0. It's greater than 1/2 times 0 plus 1. So is 0 greater than 1? No. So this means this is false, right? Everything on this side's not a solution. And everything on this side is a solution. So I would shade everything over here up to the line. Now, if it's on the line, like that point 0, 1, that would not be a solution. It doesn't include the points on the line. Okay? All right. So let's graph this one. All right, again, this is a horizontal line, isn't it? And it's crossing at -1. And it's just greater than. It's not r equal to, so we're doing a dash line. And it says all your solutions are greater than, so we know that this one's going to look like this. Okay, all my solutions are greater than. And you really don't need a test point for that, but if I did plug in test point 0, 0, is 0 greater than -1? Yes. Okay. All right, this one, what type of line is that? There's no y. So it's just an x, so it's saying cross x at -4. Whew, I don't have room on this graph. Let's make this 4, this 2, 2, 4. How about that? All right, so we're going to cross, and it's a solid line because I got r equal to. And it says everything's less than or equal to, so we're shading over here because less than is to your left. All right. So let's put this one in slope-intercept form. So we're going to minus x. So this one, my slope is what? -1/1. My y-intercept's -4. Oh, man, these graphs. They're not big enough, are they? Let's make this 2, 4, 6, 8, and make this 2, -2, -4. How about that? And these will still be 1, 2, 3. All right, so our y-intercept's here, and we're going to go down 1. I can't, so I'm going to do the opposite. Up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. So we got, again, solid line, and it said everything's less than. So we're going to be shading this way, and we can verify it by using the test point 0, 0. 0 plus 0 is less than -4. Well, that's false. 0 is greater than -4, so this is false. So this side's true. That's where I shade. And it's under the line. So it's right. Let's put this one in slope-intercept. So minus x, and then we're going to divide by -2. What happens with our inequality sign when we divide by negative? Right, it flips. So we're going to reverse that sign, and 0 divided by anything 0, so we're just going to leave that alone. -1 divided by -2 is positive 1/2 x. So my y-intercept 0, up 1 to the right 2, or down 1 to the left 2. And this is just greater than, it's not or equal to, so we're going to do a dash line. And it says everything's greater than, so that would be above the line. But let's use a test point. Here, the test point 0, 0's got something in it. So let's use this test point of 1, 1. Okay, so is 1 greater than 1/2 times 1? Yes, it is. So this is the solution. So this side is shaded. Okay, all right, let's look at some lovely word problems. Okay, so you can spend at most, let me get where you can see it, you could spend at most $10 on grapes and apples for a fruit salad. Grapes, so at most $10. Grapes cost $2.50 per pound, and apples cost $1 per pound. Write an inequality that represents the amount of grapes and apples. So the amount of grapes and apples you can buy. Identify and interpret the two solutions of at least two solutions. Okay, so let's say that x is going to be the amount of grapes, and y is going to be the amount of apples, number of pounds, right? Okay, so we said we're going to spend at most. Am I going to go over $10? If I said I'm going to give you at most 100 as a grade, am I going to give you 105? No. So it's going to be less than or equal to 10. So this is money, right? They got that dollar sign, money. So we're going to be using these monies, these amounts. All right, so grapes, they're $2.50 per pound, so that was x, right? So $2.50 per the number of pounds of grapes that we got, plus how much am I going to spend on apples? Well, apples are $1 per pound. Okay, so we need to graph this. So we're going to, if you want to put it in slope-intercept form, or we could do x and y-intercept. Up to you. Let's practice x and y-intercept for a little bit. My x-intercept would be, my pen's not working though, would be 250x less than or equal to 10. We cover up the y, right? So x would be less than or equal to 4. And then for my y would be less than or equal to 10. So my y-intercept's 10, and this is 4, my x-intercept. If you wanted to be a little bit more accurate, you could put this in slope-intercept form, which would be y is less than or equal to negative 250 x plus 10. So negative 250 would be the same thing as negative 5 over 2, wouldn't it? So down 5 to the right 2. So here's our solid line because it was r equal to, and that's a pretty bad line, but we're good. All right, so it says identify and interpret two solutions. Well, where would our solutions be? It said that it's less than, right? So my solutions are going to be in this area, okay? So I can pick any point. So let's just pick a point here. And this is at the point 1, 2. So this is x and this is y, right? So the point 1, 2 would mean I got 1 pound of grapes and 2 pounds of apples. I could buy that. What's another combination I could get? I could get right here, couldn't I? I could also get right here on this line at 2, 5. So if I did 2, 5, that would mean 2 pounds of grapes and 5, keep my colors, 5 pounds of apples. Because they're on the line, it says are equal to. So if I did that, if I know it's on the line, I know I'm spending $10, right? So any of these combinations here would be less than or equal to $10. Okay? All right. I kind of used, kind of went into my word problem, the other one here, didn't I? Okay, well, let's look at this one. I don't want you to get this mixed up with that, but I don't want to erase it either. Well, I guess I can't I? It's video, so it'll just show me erasing it. Oops, better wrap this up. Running out of time. Let's go ahead and erase this. Let's do our new one here. Hold on, y'all. I'm gonna plug this up. There we go. All right. You can spend at most $12 on red peppers and tomatoes. Okay? So it's just like the grapes and apples, y'all. So we're going to say the red peppers are $4 and tomatoes are $3. So let's say that X is, I did my wrong colors. X is red peppers. The amount. Number of pounds, right? And then Y will be the number of pounds. Oh, what did I do there? The number of pounds of where'd we go? Tomatoes. Okay. All All right, so our equation, let's write our equation. We know at most, so it's got to be less than or equal to 12. So $4 per red pepper, pound of red peppers, and $3 per pound of tomatoes. Okay, so let's just make a little graph here. X is red peppers, number of pounds of peppers, and Y is number of pounds of tomatoes. Okay, and I'm just going to do X and Y intercept. So 4X less than or equal to 12, X less than or equal to 3. So 1, 2, 3. And then 3Y is less than or equal to 12, so Y is less than or equal to 4. 1, 2, 3, 4. So there's my intercepts, and there's my line. And it said it's all less than, so everything in here would be a solution. So I could buy a pound of red peppers. So 1 could be a pound of red peppers and a pound of tomatoes. I could buy 1, 2, 1, 3. All right. You could do 2 pounds of peppers and 1 pound of tomatoes. Okay. All right. All right, let's look at systems. So graphing systems, we're going to do the same thing, except we're going to have to find the intersection of our shading. So let's start off with this. All right, our first equation here, y is less than or equal to 3. So we've got a horizontal line, solid horizontal line, crossing at 3. And it says everything's less than. So our shading would be going this way. Okay. All right, let's use red and we're going to graph this. My y-intercept is 2 and my slope is 1. So we're going to use a slope of 1 over 1, rise over run, right? And it's a dashed line. So we're going to graph that. And it says y is greater than. So if you want to, you can use the test point 0, 0. So is 0 greater than 2? No. So this would be false. This side would be true. So that's our shading here. Now, when we're graphing linear systems of equations, where they intersect, which like right here's the intersection, right? That would be our solution. However, we're talking about inequalities, so we have to look at where our shadings intersect. Where is there red and blue? So if I look right in here would be where all my solutions for this system of inequalities. It would satisfy both of these inequalities. Like this area would only satisfy the blue. This area would only satisfy the second equation. But this area here will satisfy both equations, or inequalities, okay? So you shade both the equations, and then where they're intersecting, where your shading is intersecting, that's your solutions to your inequalities, systems of inequalities. All right, let's look at this one. All right, we're going to make this first inequality red. So this is going to be we're going to put it in slope-intercept form. So we're going to bring this 2x over, so it'll be minus 2x, and then that minus 1 stays where it's at. All right, so let's go ahead and graph that. Y-intercept's -1, slope is -2, down 2 to the right 1, or the opposite, up 2 to the left 1. And it's not equal to, so we're going to do a dashed line. And let's plug in 0, 0. And if 0 times anything, 0, right? So is 0 less than -1? No. So that means 0, 0 is not a solution, that this side is. And it is less than, y'all. If you kind of, like I said, you can use your test point to verify. But if you look, this would be underneath or to the left, right? All right, let's do our second one here. And that's supposed to be a minus right there. So I'm going to swap, well, we're going to subtract 2x. Okay, so now I've got negative y is greater than -2x plus 3. I can't have a negative y, so I need to divide everything by -1, which means I need to reverse this. So it's going to be y is less than 2x minus 3. So go to -3, slope is 2, up 2 to the right 1, up to the right 1, carry it out, or down 2 to the left 1. So dash line, and this is everything's less than. Okay, so we're going to be going this way. It's underneath the line. And y'all, be sure, just use the test point if you're not sure. Is 0 less than -3? No. So this would, again, this would be no. So we always shade where it would be the opposite of no. So it's true. Okay. All right, so my solutions are going to be where it's red and blue, right? Where they're crossing. So it's all in this area. Does it include the line? No, because it's a dash line, right? But the line serves as the boundary. Okay. All right. Let's graph this one. 2x minus 3. So -3 is my y-intercept. Slope is 2. So up 2 to the right 1. 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 Or I can do the opposite and go down 2 to the left 1. This is going to be dash or solid. It's going to be dash because it's not equal to. Okay. And it says everything's greater than. Okay, so that's going to be above the line. Again, you could use the test point. Is 0 greater than -3? Yes, it is. So that side is true. All right. This one, y is greater than or equal to, so we got a solid line, 1/2 x plus 1. So our y-intercept's 1, slope is 1 over 2. Rise 1, go to the right 2. 1, 2. Or we can do the opposite, because the opposite would be -1, -2, right? So -1, -2. -1, -2. And we're going to be a solid line. And it says everything's greater than. So that's going to be up here. Again, if I use the test point, 0 is greater than 1, that would be false, so the test point would be false, so I shade the other side. All right, so now where did these intersect? Well, I got some red and I got some blue all over here, and it includes that line, but I get right here, and my red stops going right in here, doesn't it? So you have to be a little careful. It doesn't include this part, does it? Okay, this part here is all blue. Okay. All right. Let's put it, bring it over here, plus 2x. Bring this one. Okay. So y-intercept's 4, slope is up 2 to the right 1, or down 2 to the left 1. Down 2, left 1, down 2, left 1, down 2, left 1, dash circle, dash line. It says y is less than. So think of your line is on a spinner, and if I spin this end up, then this would be underneath, right? Or if I put the test point 0, 0 in, is 0 less than 4 plus 2 times 0? Yes. So this side's true. So I shade true. Okay. All right, let's minus 2x, minus 2x. So this one, my y-intercept's 4, and we're going down 2 to the right 1. Down 2 to the right 1. So this one is a dash line. And it's everything's greater than. So that would go, oops. Everything's greater than, so that's going to be going, hold on. I just noticed that key was wrong. Okay, so 0's greater than 4, that's false. So this would be false, so everything's shaded over here. So this was going to be a little bit different. We're all red and blue right here. Up to this red line. That's your boundary. And then your blue line's a boundary over here. Doesn't include the lines because they're dash, but it's up to. So that little piece right there, it's not included. Okay. All right. It says write a system of inequalities for this. Okay, so we're just writing a line for the equations, right? Okay, so let's look at this line. What's my y-intercept? My y-intercept's 0. And what's my slope? Up 1 to the right 1, so my slope is 1. And it's dash, right? So it'll be y something 1x plus 0. So is it less than or equal to? Well, it's underneath there, right? So it's less than. Is it less than or greater than? It's underneath there. It would be shading down, right? So it's less than. All right. And then for the blue line, well, it's a horizontal, so we know it's going to be y. And it's all your shadings up above, so it's y is greater than, it's a solid line, so greater than or equal to, where is it crossing? -2. So that would be our system of inequalities. All right, so let's write an equation for this line. Y-intercept is, I'm going to make this black. Your y-intercept was -1, and let's see, here's a point where it's crossing, so it's going up 1, 2, so my rise is 2, and then I'm running across 3, to the right 3, so my slope is 2/3, so it'd be -x plus, oops, y equals mx plus b, Miss Lane. So it's 2/3 x, my y-intercept's b. So now we need to look at our inequality. So if this is there's not any shading down, so it would have been above it, right? So it would be greater than, it was a dashed line. Okay. Oh, y'all, did y'all not see what I did? This right here is not the y-axis. Here it is. Totally screwed that up, didn't I? Ah, put your glasses on, Miss Lane. My bad, y'all. I was treating that vertical line as the y-axis, when clearly it tells me that's the y-axis. All right, so my y-intercept's still, in this case, it's -1, and from here, let's go to here. It ended up still being the same. Well, yeah, because we're doing the same line. So y is greater than 2/3 x. But I didn't want to confuse y'all. I'm sorry. And you see a while ago, we were over here doing it. That's a good example, though, to show you that even from that point to that point, it's still the same line, right? So same equation. However, this blue line, that's a vertical line, and it's crossing 3. So vertical lines are x, right? And it's shading to the left. So x is less than, solid line, +3. So here we go. All right, and last thing here. They give us a situation. We got a situation. Y'all seen that TikTok guy? Well, we got a, he's YouTube. He always starts his video, we got a situation. All right, suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. You want to spend less than $25 on both of them, but you need at least 6 pounds altogether. So we got two things going on here: money, the amount of money we're going to spend, and the amount in pounds that we're going to buy. Okay, so let's look at the money first. All right, we're going to say that, let's set our variables. X is going to be the number of pounds of flour It's going to be the number of pounds of corn meal. Okay. All right. So I need to spend less than $25. So we know we're going to have less than. It didn't say or equal to, it just said less than. It didn't say at least. It said less than. Okay, so less than $25. So how much is flour? $1.50. So $1.50 per or times the number of pounds of flour plus $2.50 per, which means times the number of pounds, which is Y. All right, so yay, we got one of them. All right, the second one. They said we have to buy, we need at least, so how do we do at least? So if I'm going to give you at least $5, am I going to give you 4? No. I can give you 6? Yes. All right, so this needs to be at least, so greater than or equal to 6. So the number of pounds of flour plus the number of pounds of cornmeal need to be greater than or equal to 6. Okay. All right, let's graph. All right, so let's do the easiest one first. This, we're going to have y is greater than or equal to negative x plus 6. Okay, so 2, 4, 6. And it's negative x, so we're going down 1 to the right 1 and carry it on out. So it's a solid line on this one, right? Okay. All right, now for the other inequality, 25y is less than negative 150 x plus 25. We're going to divide by 25 everything. So y is less than 25 divided by, what is that? What did I do here? This is not 25, y'all. It's 250, 2.5. If I divide that, it's 0.6. But since it's slow, let's hit math, enter on your calculator to get the fraction. 3/5. And then 25 divided by 2.5 is 10. All right, so let's see, 6, 7, 8, 9, 10. So y-intercept's here, up 3, to the right 5. So we have a dash line going that way. All right, so we need to do our shading. So on this one, for this line, it said that y was greater than that. So we're going everything this way. Okay. So everything that way. Okay, for this equation, it says it's less than. So it's going to be everything going down. Okay, so my solution area, there, oops, wrong color. Solution areas in these boundaries, it will include this solid line. It's everything here. Okay? Remember, this goes up to that dash line, but it includes the solid line when you're looking at solutions. So is it two possible solutions? Well, we know it can be on the line for here, so we could have a solution, oops, not here, here. We could have a solution at the y-intercept, so let's just say 0, 6. And we could have a solution right here. This would be 1, 2, 3, 3, 2. This could be a solution, that 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 could be a solution. All right, so you see, you can just pick anywhere in that area. All right, that does all for that. Bye.